Hello and welcome back. This is Unit 5 or Module 5, Lesson 6, Part 2. Okay, we did all the calculator stuff. We're going to do some chart stuff today and more calculator stuff and get going. But first of all, this is very weird because the last time I did Unit 5, Lesson 6, Part 1 was several months ago, it felt like to me. And since then, we've been quarantined with this COVID-19 thing. It's been crazy. Um, they let us into our school building to clear out our classrooms. Today is May 13th, 2020, and it's weird. Okay, there's like no one in the building. They only let like 4 people in at a time. It's crazy. All my stuff's packed up, and I had one lesson left to do, and it was this one for the whole year. So I'm going to do it while I have the time right now. It feels good to be back here, but it's lonely because there's no one in the classroom with me. And also, I'd like to give a shout out to Miss Lynch in her Algebra 2 class at Mount Sinai High School in Long Island. It's crazy, man. All right, this whole thing is nuts. And how you doing? How's it going? I hope things are going well. All right, let's get started. We left off with this chart-like thing here, okay? And I'm going to maximize the screen just so it doesn't get too crazy on us. And what we're going to do is we're going to create a normal distribution chart with the mean and the standard deviation bars. This used to be a little bit more important before Algebra 2 went to Common Core, when it was just regions before Common Core. But since Common Core came in, this chart kind of went away, but we're still going to look at it. It's still useful a couple of times, but actually the calculator is our true friend in this instance. But let's get started, okay? So what I want you to do is put a big fat line right down the middle there. Okay, split that hump right up. Come on, do it. All right? Now, I want you to put another line on each side of that center line about there, about that distance, okay? So here was our center line, and we just added these two lines here. All right? Now, and I want you to keep the spacing as best as you can about the same as here, okay? Don't put your second lines way over here. That would just be like, well, I don't know, you might have vision or depth issues. But anyways, we did the middle line, the 2 lines on each side. Well, 1 line on each side, 2 lines, I'm going fast. A third and fourth line, I guess. Okay, here's the median. Then we did a first and second. Now here's a third and fourth. And we are going to do 2 more lines, which are going to be really, really close to the end. Not quite at the end, but really close to the end. Boom. All right, here and right here. Okay, so what do all these lines mean? Let me explain. I'm glad you asked. Okay, well, the center line, that is where we put our mean. Remember, if you go on to statistics, very important, mean just means average. Okay, but I want you to use the word mean because you'll see it written in math as mean 9 times out of 10. Okay, so we'll have a number and our average or our mean goes right in that middle bar. Okay, then to the left and to the right of our mean are the standard deviations. Okay, these bars that we wrote here or drew here, okay, are going to represent standard deviations away from our mean or our average. Okay, so let's get going. Now, underneath the first bars, +1 or -1. What this is telling us is, here's our average, and if I go 1 standard deviation above the average, I'm at this bar. If I go 1 standard deviation below my average, I'm at this bar. Okay, so I will give you a more realistic situation in a minute. Let's just finish the rest of this first. I think you can guess what's going to happen in the next 2 bars. A plus and -2. Okay, if you go 1 standard deviation above, maybe you go 2 standard deviation aboves. You go 1 standard deviation below, maybe you go 2 standard deviations below. You never know. Statistics is a funny mistress. All right, now we have our plus and -3 at the end. Okay, so what does this all really represent? Okay, let's start filling in a little bit more, and I will give you an example that's relevant to you. Okay, bam. All right, so you see these numbers in red that got input here, installed here, written here, popped up here, digitally displayed. All right, yeah. Okay, so we have this, all right? 34.1% is in between the mean and first standard deviation. And same thing, 31.4 or 34.1% is between the mean and -1 standard deviations, or 1 standard deviation left. If I add those two numbers together, plus sign, I get a total of 68.2% of all of our data will fall within 1 standard deviation from the mean. That means either up 1 or down 1. 68% of the data. Now, let me give you an example that's relevant to you. You go to the doctor's office. They weigh you, they take your height, they measure you, whatever that thing is. They take on a scale and they race and they slam it down on your head. Do they even do that anymore? Anyways, it was brutal. It was brutal back in the day. So let's say all of the measurements they take at the doctor's office, you ever hear them say to your parent or to you that, oh, maybe you're a little bit taller than average. He might be in the 60th percentile of height. He might be in the, maybe you're a little bit thinner than normal. Okay, you weigh a little bit less than the average person your age. You're in the, I don't know, 40th percentile, meaning the average, these percentages, it's going to start at 0% and it's going to go all the way to 100%. Okay? The average is 50%. Okay? If you are the 50th percentile for height, that means you are exactly average height for your age, according to your doctor. Okay? If you are in the 60th percentile, I don't know, 60th percentile is higher, obviously. Okay? You are slightly taller than average. If you are 40 percentile for height, okay, you are a little bit shorter than average. But out of all the people that the doctor measures the height of, if the average is, let's say, 5 feet 9 inches, okay, they say that's the average. They do this little funky symbol. Remember, in the calculator, that means mean or average. Let's say that is 5 feet 9 inches. And they say the standard deviation, which was this in the calculator, you can put SD for standard deviation. Let's say that's 2 inches, okay? That means if I go up 1 standard deviation from 5'9", I'm going to add 2 inches, and I'll be 5 feet 11 inches, okay? If I go up another standard deviation, that means I got to add another 2 inches. Now I'm going to be at what? 6 foot 1 inch. If I go up another standard deviation, I got to add another 2 inches to that. That's 6 foot 3 inches, okay? And likewise, it works the same way backward. Okay, subtract 2 inches, it's 5 feet 7 inches. Subtract 2 more inches, it's 5 feet 5 inches. Subtract 2 more inches, that is 5 feet 3 inches, okay? Now, what is the big deal about the 68.2%? Out of all the people your doctor measured, okay, 68.2% of them are going to fall within 1 standard deviation of the mean. Okay, so 68% of them, roughly, are going to be between 5'7" and 5'11". That's what that means. Okay, that's what that represents. All right. So if the average height is 5'9" and the standard deviation is 2 inches, so I had to add 2 inches to go this way. I subtract 2 inches to go this way. Okay. Almost 70%. The doctor, measures 100 kids. 70 of them, roughly, are going to be between 5'7" and 5'11". You got your friend. He's a tall dude. He's right here, 6'3". You're like, wow, that dude, he's off the charts. And then, of course, the people that are way off the charts are the outliers. I mean, some dude's 6 foot. They're like, man, what does this kid eat? Give this kid a basketball. Sign him up for Syracuse University, and let's go. Let's go. Not St. John's. I know, you Long Island people, St. John's, New York, Syracuse is closer to where I am, okay? All right, so that's what this interprets, okay? That's how this whole chart interprets itself and represents data to us. So what I'm going to do now is we only filled in 68.2, but there's more. And when it comes to this chart, the next one is huge, okay? When I go to 2 standard deviations, I like to call that the money maker, okay? If I am plus or minus 2 standard deviations from the mean, that's the moneymaker. What does that represent? You will see questions. They will say, is this a normal situation? Is this common? is this uncommon, okay? Anything that is within 2 standard deviations of the mean is considered a normal thing, a normal occurrence. It is considered common. And this is the one takeaway then when they went from Algebra 2 Regents to Common Core. When you're using standard deviation, okay, without plugging numbers into your calculator to find percentages, this 95.4% is the moneymaker, 2 standard deviations. And they will ask you a variety of ways, and it will all represent that 95.4%. It'll be a common occurrence, okay? In the example I just gave you, 5'9" was the average, right? Okay, I add 2 inches for the first standard deviation. I add 2 more inches. This would be what, 6'1" inch, okay? And then if I do the same thing, I subtract 2 inches, and then I subtract 2 more, I go to 5'5". So even though, okay, we said almost 70% of the kids were between 5'7" and 5'11", it's common, okay? It's common. All right, sorry, I had to pause the video and address something real quick. Someone popped in. But, all right, if 70% of our data was between these two, okay, all these kids that are measured at the doctor's office that are maybe age, I don't know, 16, whatever, it is very common, okay, because we are within the moneymaker. We are within our 2 standard deviations for a child that age to be either between 5'5" or up to 6'1". The minute they get up to 6'3", I mean, it can happen, but it is not common. Okay, that is not a normal situation. Don't start calling all your tall friends abnormal. That's not what I'm trying to encourage here. But what I'm saying here is anything that is within the 2 standard deviations, and in the example I just gave you, 5'5" to 6'1", that's common. So, oh, I'm short, I'm 5'6". Oh, I'm tall, I'm 6 foot. Yeah, well, that's awesome. That is still normal for that age, okay? Some kid, I was joking around, someone was 3'7" before. That is not normal. That is outside the 2 standard deviation to the left, okay? Someone is 6'3", someone's 7 feet. You're like, sign that kid up. Syracuse, remember, he's an Orangeman. He's an Orangeman coming up, all right? That's not normal for this age, for this chart, okay? That's the biggest takeaway you can have, the moneymaker, all right? Let's finish this thing. Let's do some problems. Bang them out. We'll get out of here. All right, if I go to 3 standard deviations in purple, that covers almost everything, 99.8% of data. Even the ones that are, unusually tall or unusually short. What do we say? This was 5'3" maybe, and this was 6'3". Even your friends that hit those numbers, yes, it's not normal. They are way taller than the average or way shorter than the average, but it's still, it's within the realm, okay? Anything that is beyond that, that's considered an outlier, okay? That's considered a really, really rare occurrence, okay? Now, you won't have to worry about really rare or not. From all the problems I've seen in Algebra 2, you just got to worry whether it's common or it's uncommon. And that is why I stress the moneymaker, okay? Whether it's common or not, all right? That's the big thing you got to worry about. All right, so 0.1%, that's outside the 3, okay, standard deviations. And notice, if I add up all these percentages that are in between, okay, under the curve, I get 100%. So earlier, okay, say if we started at 0% here, and they said, okay, your kid average, they'd be in the 50th percentile. That's what doctors use a lot, 50th percentile, okay? If they're in the 75th percentile, they're obviously a lot taller, okay? If they're in the 25th percentile, they're obviously a lot shorter than the average, okay? I can't tell you if it's common or not unless I know if it's inside or outside my 2 standard deviations, all right? I mean, that's it. Okay, let's do some math, shall we? Let's here before we do that. They used to give you this on before it went to Common Core, the old Algebra 2 with trig Regents. Before it became Algebra 2 Common Core, it was called Algebra 2 with trig. It was Regents course. And they gave this to you. You'll notice this is a little bit different. I, my friends, gave you the mean, and then it just did one whole standard deviation up. Sometimes they did halves, which I kind of don't like, but hey, you know, they gave it to you in the reference sheet, you used it. Meaning, if this was 5 foot 9 inches, this was 5 foot 11 inches. Okay, sorry, that's a very bad 11. If my standard deviation was 2 inches, well, half of a standard deviation is 1 inch. So right here, in between 5'9 and 5'11, is 5'10 because I only go up 1 inch. Then I go up another inch to get 2 inches. You see what I'm saying? So it's just, to me, it's unnecessary. But anyways, if I added these two here, I still get 34.1. And if I added these, I still get 34.1, which means between these two would still be my 68.2%. If I added up everything between two standard deviations, you would get your moneymaker 95.4%, and so forth. So they gave you this chart. It is a million times easier to use the calculator. All right. The new reference sheet looks like this. You'll notice there's no chart. And what bothers me is it's the same reference sheet from algebra that you get for Algebra 1, that you get for geometry, and that you get for Algebra 2. Okay, they don't make the sheet any different. I don't know, maybe the state's just trying to save money and print the same thing out, who knows. But it's not on there. So you don't get our little lovely thing here that you can scribble up all over. So let's do some problems, shall we? Let's do some problems. And I think if I minimize this, I can use yeah, it all shows. All right, so I'm going to show you how we use this chart, but then again, I'm going to show you how to do it in the calculator, which is easier. All right, so a set of scores with a normal distribution has a mean of 50. That's my mean. So my mean is 50. And then my mean goes right in the middle. Booyah. And a standard deviation, I'm using the symbols from the calculator, of 7. Okay, so that means if I go up one standard, not a half, but 1, I'm going to add 7 to my mean. So this will be 57. I go up another 1, and I add 7, and I get 64. I go up another 1, and I add 7, and I get 71. Okay, so now let's subtract the 7, okay? Subtract 7, so I get to 43. Subtract 7, I get to 36. Subtract 7, I get to 29. All right? I filled that chart in based on my mean and my standard deviation. Okay, so approximately, this means about, what percent falls in the range from 36 to 64? People. 36 is here. Oh, that's here. And 64 is here. That's here. I don't even have to. I didn't even need the calculator. That's 2 standard deviations. That's the moneymaker. For the love of Pete's sake and everything, holy people. Here you go. That's 95.4%. If this were the old test, I would have to add all these percentages together in my calculator and get 95.4%. And that is approximately 95%. Okay? Now, I said you can do that in the calculator, and you can. In the calculator, we need our mean, we need our standard deviation, then we need like a min and a max, right? Min and a max. I don't know if they call it high, low. I forget what they call it. But here's our range. 36 is the min, and 64 is the max. So let's just do that in a calculator, and let me show you how this chart becomes obsolete. Okay? So I'm going to turn this on. There you go. I go to second vars because it says distribute in blue above that. And I want to pick normal CDF. Let me do this so you can see that. Some of you guys might be using cell phones, and it might be tough to see the screen. So I just do that, and I just do this here. Okay, 3664. And I got to pick normal CDF, not PDF, just CDF. All right? My lower bound is 36. Okay, I put this in earlier. My upper bound is 64. My mean is 50. And my standard deviation is 7. So I hit paste. Now, some of my students say they don't get this menu. They just get this thing here where they got to enter it in. You need to enter it in the same order. Your min goes first, or your lower bound. Your max goes next, and you need to separate them with the commas. Then your average. I'm sorry, I almost didn't. Yeah. And then the standard deviation thing, and then you close it. Okay. You still just enter them in that order. All right. So we said it should be 95.4%, and I hit enter, and oh gee golly gee, it is. Now don't forget, okay, this is a probability. If I want it in percent, I've got to slide that decimal over twice. Whatever. So we'll call that 95.4%, and for the case of the problem, 95%. Bingo, bango, bongo. So you see how the calculator really gets rid of this chart for us, okay? But that moneymaker, man, that's going to come into play a couple of times. Next one, all right? In a New York City high school, oh, how relevant. A survey revealed that the mean amount of cola consumed each week was 12. So I know the average is 12. Okay, and the standard deviation is 2.8. Okay, so if I add 2.8 for every one, this is going to be 14.8. I add 2.8, that's going to be 17.6, I think. If I add 2.8, that's 4, that's 20.4. Okay, subtracting is where we get the issue here. Okay, that would be 10, so that'd be 9.2 maybe? Okay, and I subtract 2, that goes to 7.2 minus 0.8, 6.4. Okay, subtract that's 4, it's going to be 3.6, maybe, somewhere around there. Okay, so assuming the survey represents a normal distribution, which is what this curve is, okay, it is not skewed left to right, hump right in the middle, perfectly symmetrical. How many bottles of cola per week will approximately 68.2 of the students drink? Okay, well, okay, 68.2%. Because I know the chart, I know that 68.2% is one standard deviation from the norm, okay, or the average. But what I would have to do is this. I would have to look at each one of these intervals, okay, and I would have to add up the percentages in between them, okay? This percentage right here is the only one, if I add it up, will give me 68.2%. That is from 9.2 to 14.8. Badoosh. There you go. Okay, that's a real good problem they would give you a chart for. I wouldn't expect them to give you one like this on a Common Core exam, but that's definitely a Regent style question in Algebra 2 with trig before it went to Common Core. Okay, you would need that chart in my opinion. All right, here we go. Ready? The heights. Okay, now this is an actual exam question off of the June 2016 Algebra 2 Common Core exam. Okay, the heights of women in the United States are normally distributed. That means to me bell curve. I can use mean standard deviation with a mean of 64, standard deviation of 2.75. The percent of women whose heights are between 64 and 69.5 to the nearest whole percent, so I'm rounding, is what? Okay, I have a lower limit or a min. I have an upper limit or a max. I like using min and max. I hate lower and upper, but hey, that's what it says in the calculator. Here's my standard deviation, badoosh, and here's my mean. Bam. That's completely right in the calculator. Okay, so let's do this. Let's lower this down here so I can see everything. Okay, and the average was 64. So again, I'm going to turn this on. I'm going to go back to second vars and pick normal CDF. And I'm going to just put my numbers in. Okay, 64 was my mean. 2.75 was my standard deviation. Of course, I'm putting that in lower and upper, so I should change that. Wow. Yeah, my mean and my lower, or my min, are the same value, 64. My upper is 69.5. That was coincidental. Now my mean happens to also be 64, and my standard deviation is 2.75. I paste that on there and hit enter. And I say that is roughly, okay, now they want that to a percent, to the nearest whole percent. I slide my decimal over twice. I get 47.7%. If I round that to the nearest whole number, this is 5 or bigger, that's 48%. Gadoosh. And number 2. Number 2, we're doing good. Kids are doing good. Doing good. Stop it. You don't even need me. All right. This is also off the 2016 Algebra 2 Common Core exam. Question 35, this is a short answer one. 55 students attending the prom were randomly selected to participate in a survey about the music choice at the prom. 60% responded that a DJ would be preferred over a band. Naturally. Members of the prom committee thought that the vote would have 50% for the DJ and 50% for the band. A simulation was run 200 times. Each of the sample size, 55 students voting, okay, because that's what they have actually voting, so that's what their sample is, all right? Their computer-based simulation is going to have 55 votes. Based on the premise that 60% would prefer a DJ. The approximate normal results of the simulation are shown below. So I look at this right here. Okay, here's my mean. Okay, my standard deviation. Okay, and these, if you look here, don't automatically assume this is standard deviation. Okay, standard deviation is right here. And here's my means, 0.602, so about 60%. Okay, that seemed pretty accurate, but those are just labels on an axis. Okay, that is not the standard deviation. This is right here. Please make note of that. Okay. Using the results of the simulation, determine a plausible interval containing the middle 95% of data. Oh, children, that's my moneymaker. Okay, I am going to spell outmaker. I'm that excited. Oh, in fact, I should just do that. It's bam, moneymaker. I know that is my mean. Okay, plus or minus 2 standard deviations. Okay, they went to the nearest hundredth. Okay, so I look up here and I know my mean is 0.602. Okay, so I take 0.602 and I add and subtract. My standard deviation is 0.066. So here's where you can't make the mistake, 0.066, but it is 2 standard deviations. When I add them, I'll get my upper bound, and when I subtract them, I'll get my lower bound. Okay, that is a plausible interval. That means it's a realistic interval. It's a common occurrence. Okay, so you might not have understood that this meant common or usual, but when they say this, oh, you should know that big time. And as usual, we're going to use our calculator because we don't want to make any boo-boos. So I'm going to say 0.602 plus 2 times 0.066, bang, 0.734. And then I'm going to do the same thing, but I've got to subtract them. Please note, there is no plus or minus button. You've got to do them separately. Okay? So I'm going to take this out here, bam, here's my interval, and it is going to go from 0.47 to 0.734. How come this interval would lose a point? How come you would lose a point here? Because you need to round your values to the nearest hundredth. This is to the hundredth. This is not. Okay? So in order for that to be correct, that will stay 0.73. That is your interval right there. That was easy. All right? That was real easy. Okay? Now, let's take a look at the second part. It says members of the prom committee are concerned that a vote of all students attending prom, it may produce a 50-50 split. Explain what statistical evidence supports this concern. You do not have to go back to the chart, the problem, do whatever. Just look at what you just did. A 50%, okay? 50% in decimal is 0.50, right? Yeah. So explain why the evidence we have supports that we might get a 50-50 split. Because anything in this interval, okay, so anything in the interval, I hate writing, of 0.47 to 0.73 is a good possibility. It's common, right? It's a good possibility. Okay, and 0.50 is in that interval. You could have said it one of a million different ways. Okay, you could have said, yes, 50% is 0.50, and that's in our plausible interval above. You could have said that, okay? But this is a better explanation. Well, it's better because I wrote it, and in my mind, it seems better because I understand it. But you could have written it one of a million different ways. Anything in the interval from 0.47 to 0.73 is a good possibility. And 0.50 is in that interval. Guess what? 0.70 is in that interval. It's a good possibility. 0.62 is in that interval. 0.48 is in that interval. Any of those have a really good possibility from coming up. Those are common occurrences. There you go. Moneymaker, children. Moneymaker. August 2016, Algebra 2 Common Core exam had this multiple choice question on there. The lifespan of a 60-watt light bulb produced by a company is normally distributed with a mean of 1450, okay, a standard deviation of 8.5. If a 60-watt light bulb produced by this company is selected at random, what is the probability? That means decimal. I don't need a percent. And you can see our four choices are in decimal form. That its lifespan will be between 1440 and 1465. This looks like a lower and an upper limit, which you know I like to call them mins and maxes. But we have a mean and we have a standard deviation completely in the calculator. All right, clear this out. Second, VARs. All right, pick 2, normal CDF. My mean is 1450. My standard deviation is 8.5. Okay, my lower bound and upper bound are, okay, dang it, I did it again. Holy smoky poops. 1440, I put my mean and standard deviation because they're listed, and the problem first, I put them first. So 1440 is the lower limit. 1465 is the upper limit. The mean there, children, is 1450. Yes, 1450. I didn't even have to move that. And the standard deviation is 8.5. Let's double check that because, you know, being quarantined makes your brain work funny. All right, and if I hit enter, and I hit enter one more time, 84.1%. So that's really, if these are all rounded to the fourth decimal, okay, 10,000th place. So I should round it there. It would definitely go up to the 4 would go up to a 5 because the number after it is 8. Bam. Right in the calculator. If you don't make mistakes like Mr. Visca, well, you can make mistakes. Screw that. You can make mistakes. Just catch them. You learn from your mistakes, all right? I didn't. I did the same thing twice, but hey, you know, I'm special. Now, next problem. Again, off the August 2016 Algebra 2 exam. Number 12, so we have some choices here. Yes, we do. A candidate for political office commissioned a poll. This is appropriate because we have a presidential election coming up in 2020. His staff received responses from 900 likely voters, and 55% of them said they would vote for the candidate. The staff then conducted a simulation of 1,000 more polls. In each one of those 1,000 polls, they simulated 900 voters, assuming that 55% of the voters would vote for their candidate. The output of the simulation is shown in the diagram below. Okay, so I'm looking at this thing here. Now, 55%, that's the average. These are not standard deviations. It does not list standard deviation anywhere on here. Okay, those are just labels on the horizontal axis here of our chart. Okay, so don't make that assumption that that's what it is. So we come down here. Given this output from this data, this table we have, assuming 95% confidence level, oh my goodness, it just keeps on coming back again and again. It's either a moneymaker problem or a calculator problem. All right, here we go. 95% confidence level. The margin of error for the poll would be closest to. Now, when they're asking us for this, what's the margin of error here? Okay, they're saying, okay, how far left and right can I go to achieve this? Well, 2 standard deviations. Yeah, but we don't know what the standard deviations are. But what they do give us down below are some choices here. Okay, 4 choices for margin of error. Okay, let's start with choice 4. If I go 0.12 to the right and to the left of my average, that'll bring me to 0.67. And if I subtract 0.12, it's 0.33. Yeah, 43. I'll be okay. That doesn't include 95% of the data. That includes 100% of the data. You see, if I go from here to here, okay, that includes 100% of my data, not 95. Okay, so it can't be this. Whop. Let's try 0.06. Okay, so now I'm going to go 0.06. If I go 0.06 this way, ooh, I get to 61. And if I go 0.6 this way, I get to 49. Again, that includes 100% of my data. That is not 95%. Can't be that one. All right? My data is all these bars in case you weren't catching on, okay? Now, keep in mind, I want an interval that's going to give me roughly 95%. So I don't know. I mean, probably somewhere like around here and here is 95%. I don't know. That looks like a vast majority of the data. Oh, mister, maybe it looks like it's here and here. Okay, I get you. We're approximating. Okay? I'll give that one to you. Maybe it looks like that. Who knows? All right, so let's take a look at 3. Okay, if I go 3, I go to 58, and I go to 52. That goes from here to here. That looks, I mean, maybe that's 95%. Okay, maybe, so this is maybe 95%. So now let's do, and we'll do this in red. Okay, so that's maybe. Let's do 0.1. If I go to 0.1, that's going to be 0.56, right about there, and 0.54, which is right about there. So if I do lines, I mean, that is definitely not. That is not 95%. I mean, maybe half, maybe 40 to 60%, somewhere there, but that is definitely not 95%. This is the best answer we have, that if I move left and right, my margin of error, okay, going left and right of my average, would be closest to 95%, which is our moneymaker. Okay, that one was a little confusing with the way it was worded and all that jazz, but I hope my explanation kind of broke it down so you kind of understood. Oh, this is a great problem. Again, August 2016, Common Core, short answer. Elizabeth waited for 6 minutes at the drive-thru at her favorite fast food restaurant. 6 minutes! Oh, you know how pissed I'd be if I waited 6 minutes? Especially with this quarantine. I go to McDonald's, all I want is a McDouble. Just no pickles. I'll take the onions, just leave no pickles and fry. Okay, sir, I want 2 apple pies too. But sir, we're at the apple pies are going to take about 10 minutes if you want to just pull ahead. 10 minutes? Oh, drive me crazy. Anyways, Elizabeth waited 6 minutes at the drive-thru for her favorite fast food restaurants the last time she visited. And she was upset. This woman was pissed, okay, about having to wait that long, okay? Just promise me something. If you wait 6 minutes, don't do one of those things where I'm going to see you on YouTube like throwing food over the counter at employees. That's just dirty. Don't do that. Just don't do that, okay? So anyways, the manager, now she notified the manager, like, I had to wait. She had her little bob side cut, like, you know, I had to wait 6 minutes. And the manager's like, ma'am, I assure you that your experience is very unusual. Ooh, that word is jumping out to me. That is unusual, and that won't happen again. So, what does the company do? They do a study of customers commissioned by the restaurant, and they found that an approximate normal distribution results. Oh, bell curve, great. Love it. All right. And the mean was 226 seconds. The standard deviation was 38 seconds. Okay, so I've got a mean. That's 226 seconds. I got a standard deviation, which is 38 seconds. All right. Given this data, using a 95% confidence level, I know that is the mean plus or minus 2. And I'm going to do this for standard deviation, because I should do that here for standard deviation as well, a little circle with the tail. Was Elizabeth's wait time unusual? Anything in here is common. Anything in here is usual. So we got to see if her wait time falls in that interval. Here you go. Ready? 226 plus and minus 2 times 38. Okay, let's try and do this fast mentally. Okay, so it's going to be 226 plus or minus 76, which means if I add 76, it's going to be a 12, carry the 1, 0, 302. If I subtract 76, it's going to be a 0, 5, 150? 150? I should check that in a calculator. You know, I got quarantine brain right now. So, and if the calculator were to pop back up, yeah, there you go. And turn this on. And I say 226 plus, and I will do this, 2 times 38, because I'll make the calculator, yep, plus 2 times 38. And we're going to make the calculator do all the work. That's 302. And I'm going to do the same thing, and I'm just going to do minus here. Yep, I would do the same thing, but the minus. This time it's not my quarantine brain. The board is slightly off with a touch here. And 150. So we're good. Okay, I double checked my work, which you all should. Now, this is considered normal or usual wait time. Normal or usual wait time. This woman waited 6 minutes. How many seconds is that? Well, it's 6 times 60. That's 360 seconds. Is she in this interval? No. She is not in this interval, so her wait time is not normal. Her wait time is unusual. It is not usual. So it says justify your answer. Your justification is your math, but don't forget to answer. Okay? Was Elizabeth's wait time unusual? Yes. It was unusual. Okay? It is not in that interval. Absolutely not. Don't throw food at fast food employees. During this quarantine, they're like mandated, mandatory workers. We need them. I need my McDouble, no pickle. I do. Every time I go over this in class, this is a tough one, number 36. I say that out of the work you do, you should be able to get the part A easy. Part B might be tough. So you should be able to get at least half of this problem. But I'm going to go over it all naturally. August 2016. Ava designed an experiment to determine the effect of a new energy drink on a group of 20 volunteer students. 10 students were randomly selected to form Group 1, while the remaining 10 made up Group 2. Each student in Group 1 drank one energy drink, and each student in Group 2 drank one cola drink. 10 minutes later, their times were recorded for reading the same paragraph of a novel. The results are below. So, we said that Group 2 drank cola, and Group 1 was the energy drink, all right? And then they read a paragraph and they sped through it. So part A says, and this is the part I think you can get, Ava thinks that drinking energy drinks makes students read faster. Using this table, this information, explain why her hypothesis may be incorrect. It can be one of several different things, but here's what jumps out to me the most. You see the two fastest times? They're actually in the cola, not the energy drink one. The average, okay, the average is faster for energy drink, but the two fastest times were the cola drink. So if I use that data to prove that she's wrong, okay, so explain why she might be wrong, you just say the two fastest times are under the cola column. Okay, that's it, point blank. You could say, well, maybe kids didn't sleep. Yeah, that could be true, but that's not using the information in the table. You want to use the information in the table, okay? And you just want to say, you could say the two fastest, you could say the fastest time was under the cola, okay? But I just happened to notice there are two that were the fastest time. Might even be a third one, 16.9? No, that's less than that. Okay, good. This is the one that I think is going to throw people off. All right, let's do this. Using the given results, Ava randomly mixes 20 reading times, splits them into two groups of 10, and simulates the difference of the means 232 times. Okay, group 1 is the energy, which is 17.7, and group 2 is the COLA, which is 19.1. Those are going to come back into play. Okay, so it says here, Ava has decided that the difference in mean reading times is not an unusual occurrence. So whether it's usual or if it's not unusual, that means it is usual. That means it is common. That means it will be in our 95% interval. It will be in our 95% interval. Wow, see, that is way off. I guess I'll have to be lower. There you go. Now, group 1 was 17.1 minus group 2. I'm looking at the mean times here, okay? Was 19.1. Was that 17.7? Yep, 17.7. So if I subtract them, okay, if I take the 17.7 and subtract 19.1, I get negative, oh my goodness, why don't I just do it this way and then just make it negative? That's a 4, that's an 8, 1.4, negative 1.4, okay? So negative 1.4, and again, because we got quarantine brain, we're going to check this in a calculator just to be safe. 17.7 minus 19.1, 0.1, boom, negative 1.4, we're gold. Okay, negative 1.4, okay, negative 1.4 falls right, okay, oh my goodness, I gotta count these, 1, 2, 3, 4, 5, 6, okay, each little slot here represents a tenth, okay, so negative 1.4 is right there, right here, the top of that little column is negative 1.4, okay, now there are a total of 232 simulations, okay? How many simulations, okay, what percent, how many simulations did it take to get here? Okay, so I'm going to count these. This bar right here counts for 1. You can see because it comes up to the 1 bar. This is 2, 1, 1. This is 5. This is 2, 2, 3, 2, 1, 2, and then 1.4 gives us 3 again. So I've got to add up all of these numbers, okay? 1, 2, 3, 4, 5, 10, 11, 12, 13, 14, 15, 18, 19, 20, 21, 22, plus 3 is 25. So this low end right here represents 25 out of my 232 simulations. And guess what if, well, guess what if I do 25 divided by 232 gives me, if I slide that twice, okay, I get 10.7%, okay? If I start at 0 and I go here, and this is 10.7%, that is within my moneymaker. Let us not forget, and I'm going to erase some of this stuff. Our moneymaker makes up 95%, right? So if I go from here to here, let's say, and that's 95%, isn't, I have 5% on the outside, so 2.5 and 2.5. Doesn't that make up the outlier? This is the not common stuff. This total 5% is not common. This 95% is. If I start at 0, I pass 2.5% to get to 10.7%. Do you see what I'm saying? This right here is 2.5%. Okay? Uncommon here. Once I pass it, I get into the common area. 10.7 is past. Okay? It is past my 2.5%. Okay? So explain your reasoning. You can just say, okay, 10.7% is our, what do we call it, negative 1.4 per her, what, study, I guess she did, per her study. And that is within 95% common occurrence. That one would have been tough to get. Part A would have been easy. Okay, I'm going to give you that one. That one's tough to. This is the last one. Okay, I normally don't have these go 50 minutes, but I don't know when I'm going to be back here, so I want to do this in one shot. January 2017, Algebra 2 Common Core. This is more recent by a year. Anyways, in 2013, approximately 1.6 million students took the critical reading portion of the SAT. Boo! The mean score, the modal score, and the standard deviation were calculated to be 496. In case you didn't know, that's the mean, because mean is listed first, and so is 496. The mode is 430, and the standard deviation, which is listed third, is the third number, 115. Respectively, which interval reflects 95%? Moneymaker. We know that is the mean plus or minus 2 standard deviations. Okay, my mean, 496, plus or minus 2 times my standard deviation, 115. I mean, that was the easiest thing, okay, to do. But Visca, I don't see that. Yeah, because when you multiply 115 times 2, you get 230, okay? And make sure the most difficult part of this problem is looking at the numbers, because this one started with a 4 and had a 230, and I looked at that for a second and almost circled it. They assume maybe sometimes you don't put the 2 here. That's why they list these two. But you are better than that, and you know that that 2 belongs there. We are done. The year has been wonderful. I love you guys. Take it easy. And if you have to take the test in August, I don't know. I think they might just give you credit if you pass the class. Who knows? But if you take the test, you will knock it out of the park, because you, my friend, you're smart. And people love you. All right? Goodbye. Take it easy. Thanks for joining in Long Island. I love New York City. Love it. All right. Take it easy. See ya.